Και τώρα να περάσουμε στο session 3, Energy Efficiency EinB in the Industry, συστήματα ενεργειακής απόδοσης και εξοικονόμησης στη βιομηχανία, αλλά και όχι μόνο. Θα ξεκινήσουμε με την πρώτη παρουσίαση από τον κύριο Αλεξάνδρου Kontoyanis. Mr. Alexandre, please welcome to the podium. Θα μιλήσω στα αγγλικά για να μιλήσω στον κύριο Alexandre. Alexandre Kontoyanis is a technical director of MC Consultant Latam. He's an ASHRAE distinguished lecturer. Mr. Kontoyanis will speak about energy efficiency data center cooling system, how to. Just a brief introduction about the topic. It is known that data center cooling systems are the main villains of energy consumption. But while they are part of the problem, they are also part of the solution. This presentation shows the main problems found in cooling systems from the point of view of maintenance and operation, and how to mitigate it. Ο κ. Kontoyanis είναι ελληνικής καταγωγής, αλλά έχει μεγαλώσει και έχει γεννηθεί στην Βραζιλία. Μιλάει λίγα ελληνικά. Είναι distinguished lecturer της ASHRAE στο κομμάτι του data center, που συχνά επισκέπτεται διάφορες χώρες και συμμετέχει και δίνει ομιλίες πάνω στο κείμενο και έχουμε τιμή να τον έχουμε μαζί μας σήμερα. Όσο αρνούμε το τεχνικό ζήτημα, θα συνεχίσω με ένα μικρό βιογραφικό του κ. Kontoyanis. Alexandre Kontoyanis has been working for over 12 years in the critical mission area in the areas of operation and maintenance of data centers. Alexandre holds a degree in mechanical engineering and postgraduate degree in project management. He currently holds the title of specialist in data center design and operations by BCD Academy, Accredited tire specialist and sustainability advisor by the Uptime Institut. He has extensive experience in data center specification, having participated in ISO 15001, Uptime tire, and operational sustainability certifications. Νομίζω ότι ο κ. Kontoyanis είναι ένας expert στα data centers. Είμαστε αρκετά τυχεροί που θα μας δώσει το φως το κομμάτι. Παρουσίαση, δεν ποιος είναι. Να αλλάξει. Otherwise, we will make the presentation by heart, dear Alexandre. I'm sure you are so specialist.
It will work.
Okay.
If you go there,
Switch.
Splicing display settings, Alexandre, você consegue. Display settings, você consegue virar a página. Aí. Isso, essa aí. Só. Aí.
Olha, great.
It's not working too. Just use the...
Καλημέρα σας. Με λένε Alexandre Kontoyanis, είμαι από τη Βραζιλία. Έχω ελληνικές ρίζες, αλλά δεν μπορώ να κάνω αυτό στα ελληνικά. Δεν είναι τόσο καλά. Όπως να θα μιλήσω αγγλικά. Εντάξει. Well, today we will cover a huge topic. We could talk a month about this. Data centers are mushrooming everywhere, but let's try to shrink to 20 minutes. As Juliana said earlier, we are from Distinguished Lecturer Group. It's a program from ASHRAE that brings specialists from every topic to chapters to talk about this. So we are all volunteers, and we always need help. So please join us, join any chapter. We need every hand we can. And something important, my opinion not necessarily reflects the ASHRAE's opinion. It should, but not necessarily. So the agenda we'll cover today is global and local context of data centers, consequences to the world. Let's talk about a little about the TC 9.9 is a technical committee that works with data centers. Let's look where are the best opportunities in the point of view of energy efficiency. And for the last, I will show you a roadmap how to achieve energy efficiency in data centers. Global context. This was the last research I found from IEA. It's the Energy Agency of the United States. On 2001, we used to consume 1 to 1.5% of all energy produced in the world. 2023, it's around 4 to 5% of all energy produced in the world. This is huge. And everywhere in the world has a forecast of growth between 6 to 12% a year until 2028. Where we are going, I don't know. But I know something. We need to look to energy efficiency, operational carbons, etc. We need to look at this. We are a huge player right now. Last September, largest Q2 ever recorded for data centers demand in Europe. We are growing. Of course we are growing. Let's take a look at Greece. I found this in the internet, the sources here, data center map, I use it a lot. It's not always very accurate, but shows an idea. Here in Greece, you have around 18 data centers, which more located in Athens and Thessaloniki. That's important because we need to know where the data centers are, because something that's very important is the weather. Building a data center in a hot place gives us a hard time to maintain energy efficiency. And we have a cultural thing that we always build data centers with chillers. Do we need? We'll talk about later. It's good to grow 10% a year. Does anyone want to increase their revenue for 10%? I won't. Data centers should, but it has consequences. We become victims of our own success. Carbon emissions, energy consumption, and the price of energy rising. We need to face those challenges. How? And some cities are having trouble. Singapore, for example, declared a 3-year moratorium on new data centers. Can you imagine a country stop building data centers? An industry that is high profitable. It's a huge decision because they couldn't handle anymore. The energy grid cannot handle those data centers. And now new data centers must achieve a PUE. It's a metric of efficiency, power usage effectiveness, 1.3. It's very efficient data center, a PUE 1.3. Last Uptime research from last year, the average PUE you have in the world is 1.55. PUE is simple. You take all the energy consumed by the data center in a year and you divide by the energy consumed by IT. In theory, when you have one, it would be the best. all the energy consumed was for IT. When you had 1.2, 1.3, or 2, other half of the energy was consumed by infrastructure, mechanical, electrical, water, whatever. Dublin banned new data centers. This energy company agreed to not accept any more data centers they can handle. Netherlands, new data centers only PUE 1.2. Netherlands is easier, it's older, but still very efficient. United States, there are lots of places that starts to do regulations. We need to do this. And ASHRAE TC 9.9 is our technical committee. It's it's leading this change, looking for energy and efficiency of data centers. I'm part of TC 9.9, and I'm proud to say that we released 14 books about data centers, and we keep updating everyone. This one was the last one, will be published, I hope in a month. Liquid cooling designs. It's a hot topic everywhere in the world. You can see some racks consuming 300 kilowatts on space like this. It's just too much heat. The only way to cool is by liquid. Well, it's just it's opportunity. TC 9.9, you join us. You don't have to be a member of ASHRAE to join TC. Of course, you should be a member of ASHRAE, but you do not need. You just go to the ASHRAE website, join TC. You can join how much TCs you want. Duct design, energy efficiency, carbon things, everything you have TCs on ASHRAE. Join. You keep update from what we are doing. You can talk and comment about what we are doing. We're always looking for new perspectives. The main of these 14 the main one is the first one, the thermal guidelines, that in the industry almost everyone knows. They talk a lot of things, but the main is about the temperatures we are looking on a data center. As you can see here, I'm psychometric chart, we have 5 areas here. A red one we call the recommended envelope. It means the temperature of the air at the entrance of the IT, that is important, at the entrance of the IT should be here. 2001, this area was a point. Can you imagine control a huge data center to achieve one temperature at one humidity? It's almost impossible. Now you have this area, and you can choose whatever you want to be. This area is the most, is the balance between risks and efficiency. And you have those another areas, A1, A2, A3, A4, it's allowable limits for each type of equipment. Data centers almost always work at A1. So we're talking about 18 to 27 Celsius degrees. It's -9 dew point here, around 9 to 12% of relative humidity. Here, 15 degrees Celsius dew point, and here, 70% of relative humidity. Last edition, we just made an update. ASHRAE always funds research what the industry is asking. And one question is, what does affect, if I have a high humidity environment, what does it affect? And we found that it affects the corrosion of the IT equipment. And we found if you have an environment of low contamination, you can rise up to 70%. But if you have a high contamination environment, you should drop to 50%. What is low contamination and high contamination? How can I know? Testing. It's cheap. It's a cheap way to test. You expose copper and silver in an environment for 30 days, and you send it to a lab to calculate how much was that corrosion. And if the corrosion is 200 angstroms per month for copper and 300 for copper and 200 for silver. If it's more than this, you should drop your humidity limits. If it's less, you're fine. We borrowed from ISA classes. You should go for the mild. If you're a G2, G3, or GX, you should drop your humidity. But let's go for the best part. Where are the best opportunities? This is a typical data center with a PUE tube. It means the energy consumed by IT is here, one, and the other, same amount of energy spent or consumed in a year is divided in the infrastructure. You see here, mechanical and electrical. As you can see, compressors consumes a lot, chillers, or DX systems. Fans consume a lot. UPS, of course, consumes a lot. But when you look for an efficient, typical efficient data center, look at the difference of the consumption of the compressors or the fans. Look now the difference between average UPS and a state-of-art UPS. It's 5% of 5%. And you need to invest a lot of money to change your UPS. So we can say that the best opportunities are in the compressors and the fans. And we'll talk a little. You have, of course, humidification, etc. But in 20 minutes, let's talk those two, those more important. Question: are chillers necessary? It's a fair question. Many times yes, that's true. But the question is, do the chillers need to operate 24 hours per day, 35, 6 days a year? Almost always not. And the solution is economizers. Let's go with two types of economizers here. This is an airside direct airside economizer. It's the simplest we have here. We have data center here, the racks here, cold aisle, hot aisle, and you have the air coming straight from the outside to the inside. Of course, you have silencers, dampers, filters, humidificators. You have here a DX coil to backup. You never know when it's hotter than you expect outside. You have the fans here, and the air goes to the racks and goes back to the outside air. Very simple. In a point of view of an engineer, very simple system. Advantages: high efficiency. We have the approach. The approach is the difference between this temperature that we are looking for the standard and the outside temperature. The difference between those two is 1 to 2 K. It means if you want 20 degrees Celsius here, it should be below 80, 18 or 19, for example. So it's very efficient, and it's simple, but you have some problems. You mix the outside air and the inside air, and you don't have control of the quality of the outside air. It can be polluted. You can have, for example, if some trees start to burn around, there will be smoking on the data center. It's a problem. You use a lot of filters, and this is a thing that matters now. Continuous use of MERV 13 filters can generate a large volume of waste. It matters too now. And it's hard to control the humidity outside. To do this near the sea, for example, it can be a problem. I'm back. Okay. And we have the indirect air side economizer. Can you see the difference here? The difference is we have now a heat exchanger here, air to air heat exchanger. Now we do not mix anymore. the air between the outside air and the inside air. Of course, you have some air coming from outside to pressurize the place, but it's just a little bit. And have the main advantage, I think, you do not mix anymore the air streams. You use less filter. And it's recommended for the city where the outside air may be too polluted or too humid. But of course, you have its advantages. We lose a little efficiency. Now, the approach can be around 4K to 8K. It depends of the machine you're buying. This is almost directly proportional to the size of the heat exchanger. So if you want a very efficient heat exchanger, it goes big. It's expensive. Sometimes you don't have the space to do this. So it goes to 4 to 8. Most efficient is 4. Let's see outside conditions. This is conditions for Thessaloniki. I took on the Energy Plus site, website. Each point is an hour of Thessaloniki weather. We look at this and we draw some lines. For example, I want in my data center 24 degrees Celsius. It's okay for the standard. It's 18 between 18 and 27. I bought a very efficient indirect airside equipment, so it's 4K of approach. I have an IT delta T of 12. It's very much common this rise of temperature and IT temperature. What we see is below this line, it's 20 degrees Celsius, we have book temperature here. Below this line, all those points, all those hours in Thessaloniki, we could do without chiller. From this line to this upper line, we can do partially. Up this line, we cannot do. We need to run chillers. I think, I did not calculate that, here is around, below this line is around 80% of the time. 80.5 or 85, 9. So what I'm saying is, in Thessaloniki, if you want to run your data center at 24 degrees, it's a pretty common temperature, you could run without chillers 80% of the year. If you raise your temperature even more, go to 27, still allowed, still recommended by the standard. I have only 4 hours and it's very close. It should fall in the allowable temperature. What I'm saying is, new data centers on Thessaloniki should run without chillers. I know it's hard to, as a designer, I know it's hard to say this to your client. You do not need chillers because you're a very conservative industry. But here are the data. You can, and you should look for it. This is the 0. Above this, you have 0 economizer. You don't have only 4 hours, I think. Well, Alexandre, I have a data center. They are already constructed. They have chillers. What can I do? First, check water temperatures. Much of data centers that I visit, chiller water temperatures around 8, 9 degrees. Why you operate that cold if your IT can take care up to 27? I don't know. You should rise it for 12, 13. You save some energy on chillers. They say, and use chilled water to control the humidity. Theoretically, if you run around 13 degrees, your coils control the humidity below the 15 that we recommended as ASHRAE. So you don't need to run at 8. Efficiency of your chiller. How is the COP of your chiller? You have another things to evaluate, for example, IPLV, but let's check the COP. Let's not check the COP. Let's check again. You have chillers right now, the COP7, very efficient COPs. But most of data centers, all data centers, work with chillers of 3.9 to 4. I know it's fair, but you can go to the extent. So if you have to retrofit your chiller, look for this. It's expensive, yes it is, but the operation cost of the data center is much higher than investment cost. It's much higher. Another thing that I saw many times is that the fan coils, the press units, are not working in 100% sensible heating radio. They are dehumidified, and it's the worst thing that you can do. We don't have latent heat on the data center. It's on sensible rate, almost 100%. So if you're working around 80%, that is very much common, you are losing energy. You are dehumidifying your data center without, you don't need to do this. So you are losing energy. The state-of-art designs control humidity exclusively in a DOS. It means you have a machine that's dedicated to outside air. You control the unit only on this machine. And reduce the condensing temperature of your chiller as much as possible. We know that the compressor work, it means the energy that it consumes, it's proportional the difference between the evaporation temperature and the condensing temperature. If you drop your condensing temperature, your compressor will work less and you save some energy. You should work as cooler as possible of the condensing temperature. And the second last one that I want to talk to you is about fans. We know almost data center have redundancy, often twice as much as needed. We call 2N. I have 2N data center, N plus 1 data center. If you have the double of the capacity that you need, it's just fine because you have 100% uptime needed. Question is, it's more advantageous to keep redundant press units on standby, it means turn it off, than to keep them all running together at a lower speed. Let's check the fan laws. The fan laws basically are three laws. The speed, therefore the flow of the fan, is proportional to the rotation. So you double the rotation, you double the flow. Very simple as this. The pressure of a fan is proportional to the square of the speed. It means if you double the speed of your fan, you multiply by 4 the pressure. And if you halve the speed of the fan, you divide by 4 the pressure. And the power, therefore the consumption, the energy consumption of a fan is proportional to the cube of the speed. It means if you double your speed, you are multiplying by 8 your consumption. Therefore, if you halve the speed of your fan, you divide by 8 your consumption. Important things to say is this is a physical law. It's not from the parliament. It just happened. God wanted it like this. But in reality, connected to the fan, we have motors, we have belts, VFDs. We bring some inefficiency for this. And from the field, we found that if you change the exponent 3 to 2.3, it gets as close as can be from the reality. So if you change the exponent 3 to 2.3, you will have a good idea how much you can save in the energy. Let's see, you can use the equation like this. Let's see in reality how it would work. This is a fictitious example. We have here data center, racks, cold aisle, hot aisle, and our class on the perimeter. On, off, on, off, on, off, on, off. 2N, 4, the needed is 4 on. You can see this, the table here, from 1, 2, 3, 4, to 8, on, off, 100%, 4%. The flow, 22 88,000 cubic meters per hour, and the power, 20 kilowatts. So, on total, we need, on this data center, 88,000 cubic meters per hour of air, and we consume 80 kilowatts. If we change this, it's just an operation mode. We turn low everyone and start speed of 50% for each run, we will maintain the same flow. Right? We saw this before. But now, look at the power consumption of this fan. It's 4.06. Of course, now we have 8 turn it on. But if you do the maths, same net flow, potential save is 60%. Just changing the operation mode. Of course, you have to, your fans should be able to change its speed, VFD or an EC fan, for example. So we are looking for comparing 80 kilowatts to 32. This is a great opportunity. I like discounts of 60%. And the last finish, we build this with its fuel experience. Everyone wants to go efficient, everyone wants to go to net zero, etc., but they don't know how. I saw many data centers going, I want to go green. First thing I want to do is buy renewable energy. And I think, in my experience, it's important, but should be the last step. How much energy do you need? If you look to the picture right now, maybe it's X. But if you do some things like this, should be half of X. And normally this contract of energy, it's for 20 years time. So it will be the last step. So first, you look for IT, and I know that we engineers sometimes cannot touch this. But you should talk to the guys with IT. You should rationalize, consolidate, virtualize. Servers can run better. Then you go to airflow management. Study of the energy, set points of your air, stop work at 18 degrees Celsius, start operating 24, 26 degrees. Control supply air temperature, idle containment, you segregate the hot air to of the cold air. Then you go to the MAC, you increase set points of chillers, etc., reduce fan volume, you optimize humidification, you can use heat recovery. You have airs of a temperature of 60 degrees. I saw in Argentina one data center that has the return temperature is around 40 degrees, and the winter in Argentina is cold. And they have the knob, the place that the people work, and they heat with gas. You have a room here rejecting air at 40 degrees, and you are heating this room with gas. This is just insane. Then we go to electric. Change our bulb lamps, change our UPS, generator heaters, for example, you can change it. And then you go to energy. So here, after we do all these steps, you know how much we need energy. Then you go to renewable energy and heat recovery, for example, Canada buys your heat. On Ontario, they need heat. So they buy, if you put a heat exchanger and you start to heat the municipality water, they buy for it. It's something that you are rejecting and you can start making money. But this is the last step. The lower fruits are here. And that's it. We could talk a week about it. There is much more that we can do for data centers. And what I wanted here is to plant a seed. We can do better. Most of data centers works fine, but we can do better. And there are easy ways to do better. Look for it. Do a research. Ask for help. We will have, ASHRAE, it's looking forward to help you to get the best of data centers that you have. Thank you very much. If you have any questions, I'm here.
Thank you very much, Alexandre. Do you have questions for Alexandre? Please.
Alexandros, and I hope you very well. Excellent presentation. And if you have to choose to complete what you have already said between machine learning and AI or emergent cooling in improving what you have said on sustainability and energy consumption, what would you choose for the next step?
Tricky question. Well, we were in Chicago last month on the annual conference, and we talk a lot about liquid cooling, AI, etc. The thing is, AI applications are ultra high density, and the chips, TDP, thermal design point, are rising so much. We're talking, of course, at dinner, chips of 9 nanometers technology are dissipating 1.2 kilowatts heat from NVIDIA. This is absurd. I'm a mechanical engineer. If I didn't see, I would say it's impossible. This is an AI application, and you cannot do it by ear. You cannot, just cannot. So the applications, now we are going to the liquid cooling, but I think, in my personal opinion, and most of the guys from Thessaloniki, I think we will go for hybrid. You will still have applications of 10 kilowatts per hour, 8 kilowatts per hour, forever. Of course, you can submerge all your data center into the sea. Yes, you can. Maybe it's more efficient. Maybe. I don't know the problems with dolphins, fishes, etc. But the thing is, what we are seeing that we are going to hybrid. So if your data center has clients that use AI, and they will build a new data center, I would advise you to get ready for the immersion cooling and direct chip cooling. You should get ready for this. You will not be able to do it in air. It's a huge flow that we need, and so low temperature that will be highly inefficient or impossible. Not impossible, but can you imagine a heat sink of this height? That's it. So if you're looking for AI, machine learning, etc., you go to the liquid cooling. Direct chip or immersion cooling, you go for each one, but you go.
Thank you.
Yes. Okay, of course.
Thank you very much. A quick question. You only mentioned PUE in your presentation, but you're doing a lot of discussions whether that's the best metric. You started introducing others. What's your personal opinion about that?
PUE was the most important, I think, in my opinion, the metric we had. It's simple to use, but now we need to go deeper. First of all, government regulations asking for project PUE. I think PUE is an operational key performance index. Because if you build a data center, very efficient, 1.2, and you run at 20% of the capacity, you will not run at 1.2. It's impossible. You run 1.8. So we have new metrics, including water consumption, that is important too. You saw in my presentation. Water is important. Data centers that use water, condensed water to cool the chillers, consumes a lot of water. And some places water is cheap, some places not. And maybe in the future we'll have problem with the water supply. So we have WUE for water, CUE, carbon user effectiveness. We are starting, including Europe is the vanguard of this, new metrics to see how efficient and how environmental friendly is your data center. So PUE is just because it's easy, but I think it's not the best key. I would go, and PUE, another thing is they use PUE to compare data centers. And PUE is very tricky. You can imagine, it's easy. It's the total power divided by the IT power, or energy consumption. Where are you measuring IT? If you're measuring the UPS, you have a lot of losses between you transmitted energy, and it's computed as IT energy, but it's not. So your PUE goes down, you're very efficient. No, you're not. So I think PUE will be less used. and we start to use new key performance indicators as they come. ISO are proposing 6 or 7 new KPIs, and I think they will replace PUE, in my opinion.
Thank you so much, Alexandre.
Thank you very much. Sure.
Can you explain us, justify us again, as quickly as possible, how it is manageable not to use chillers in Thessaloniki for temperature 27? With what exactly method? How not to use chillers? With dry bulb, you mean, or wet bulb 27?
If you see here, if you can use this type, it's very many vendors has this type of equipment. If you see here,
yes.
you can use this type of equipment here in Thessaloniki.
Yes.
This type of equipment will go the outside air just flow through the
38 degrees of outside there in Thessaloniki.
but dry bulb temperature. When you have here, if you have here 35 degrees, but look at the humidity, it's around 20%. Supposedly with adiabatic cooling, you can go.
Integrate adiabatic cooling.
Yes, here.
In the system, right?
You see here, everyone, the system has a adiabatic cooling here. So you can drop the temperature, supposedly, on this case of 30 degrees, 35 degrees here, on 20%, you suppose can drop temperature up to 19, 20.
This is stuff to consider lower wet bulb adiabatic cooler below 27. It's tough.
Yeah.
The 20 is below 20. It's tough to be achievable all around, because we need to be sure that even on the hottest day, the data centers will operate. Otherwise,
but if you can imagine, if you can drop temperature, for example, to 35 to 25, you can go around this. You can do partial cooling. Your chiller is now cooling 25 to 18.
You will need the chillers. It's
yes,
possible
but
to
yes, you can use it as a backup or work with chillers. And just quick, it was just 5 minutes. We were discussing in Chicago, as the power rises from the chips, we are coming back to chillers because those applications need doing, even with liquid cooling, we will need a lower temperature cooling. So what we are doing, if you're doing a data center for 10 years now, most of consultants are advising you to maybe you don't need the chiller right now, but probably you need. So if you're building for a 10-year data center, you should get ready for a new chiller, for example. Or you can install and use it partially, for example.
Okay. Thank you very much, Alexandre.
Okay.